Okay, so here are some examples for 5-4, which is your sum and difference formulas. So I'm going to go through, I think I have 8 examples. I forgot. All right, so if you had something like this, right? The cosine of the arctan of 1 plus the arc cosine of x as an algebraic expression. I'm laughing because of what my children are watching. Okay. So one way you can go about doing this, we talked about this kind of on that last day we were in class together, is first of all, you need to recognize here that really you have one of the sum or difference formulas. And we're going to call that the cosine of u plus v. Maybe I should use a different color. So in your notes, not in your notes, in your book on page, I think it's 400, you have, God, this thing could just go, the sum and difference formulas. I think on page 400 are the sine and cosine ones. And if we were taking assessments in class, we would expect you to know these. So next year for calculus, these are something that you would have to have memorized. So just keep that in mind. All right, so back to my work here. So the cosine of u plus v, I'm letting u be my arctan of 1 and v be the arc cosine of x. All right, and remember the cosine of u plus v using your formula, it's the cosine of u cosine of v minus sine of u sine of v. All right, so like I said, if u is your arc tan of 1, you can go about making your right triangle with this being angle u. And so remember, if u is the arc tan of 1, we go about forming our triangle. Okay? So we know that each of your sides are going to be 1. And so using your right triangle trig, you know that this is going to be root 2. V, we're letting be arc cosine of x. Again, you can draw the little triangle to help you. This would be V. That would be your right angle. The arc cosine is x, so that means that your adjacent is x and your hypotenuse is 1. Using your Pythagorean theorem, this is going to have to be root 1 minus x squared. Okay, so back to the problem and how this can help us. So remember, if we're thinking of this as the cosine of the quantity u plus v, let's actually substitute in our u and our v. So we would have the cosine of, again, I'm just going to substitute in here. I don't like writing arctan, I'm writing tan. So -1 of 1, and then cosine of v, so that's cosine of the cosine inverse of x. And then it says minus the sine of your u. My u is tan inverse of 1. And then it says sine of v, so sine of the cosine inverse of x. Okay, so we want the cosine of the tan inverse of 1. Sorry about the blurriness. So that means we're looking at this triangle right here. We're trying to find what's the cosine in this triangle. So the cosine of the tan inverse of 1, so that's adjacent over hypotenuse. So that's going to be 1 over root 2. The cosine of the cosine inverse of x, that's just x. The sine of the tan inverse of 1, I'm going to this triangle and finding the sine. So that also is your opposite over hypotenuse. So 1 over root 2, not also, but I meant it's also 1. And then your last one, sine of the cosine inverse of x, we're going to this triangle and finding the sine. So that's going to be your opposite over hypotenuse. So just root 1 minus x squared. I hate doing my work to the right, but I've kind of cornered myself in here. So that gives me x over root 2 minus root 1 minus x squared over root 2. Combine your terms here. because they're the same denominator. So you get x minus root 1 minus x squared over root 2. And yes, you can leave your answer like that.